one step further today. We're going to learn how do we calculate how much colligative properties change. And we're specifically just going to look at freezing point and boiling point. So by adding solutes to solutions, we're going to learn, well, how much does it raise the boiling point or how much does it drop the freezing point? Okay. So we're going to take a few notes. Again, it's mainly practice problems. Okay, so get out something to write on, and then you do need a calculator because we are going to do a little bit of math. Okay, so colligative properties, it doesn't have to do with the identity of the solutes. It just has to do with the quantity, okay? So we care more about the quantity of solutes that makes the properties changes, okay? So therefore, we care about the ratio of the solute compared to the solvent particles. The way we express that ratio is we use something called molality. Everybody say molality. Okay, does that sound like another word that we've learned recently? Kind of like molarity. Molarity and molality are not the same thing. Okay, so we're going to differentiate them. But you might need to like highlight, star, underline molality. This is new. Okay, so to calculate molality, all we take is the moles of solute divided by kilograms of solvent. Okay. So go ahead and copy this down. Units matter. Okay, so it has to be moles of solute over kilograms of solvent. Okay, we're going to do just 2 practice problems, practicing calculating molality. Okay. So we're going to figure out what is the molality of a solution that contains 25 grams of glucose dissolved in 200 grams of water. Okay, so molality, we typically use lowercase m to represent molality. Okay. And so molality is just moles of the solute. So in this scenario, which one's the solute? Which one's dissolving? What dissolves in the water? The glucose. So it's going to be moles of the glucose divided by kilograms of the solvent, which is the water. Okay, so if you look at the info given, are you given moles of glucose? Not directly, correct? Okay, however, are you given enough info that you can calculate the moles of glucose? Okay, you know grams. So you know you have 25 grams of glucose. Can we convert that to moles? Yes. How do we get from grams to moles? Okay. Will you please find the molar mass of glucose? Anyone have a molar mass of glucose yet? I think you should be in the 180 range. Okay, so you should be getting 180.18. Okay, so divide 25 divided by 180.18. Divide these, what are you getting? It should be a small number. Okay, what are we getting?
7.2.
No, it should be tiny, less than 1. Flip it the other way. 139. I did 1.4. Let me erase. Okay. So now we can plug it into our equation. So we know we have 0.139 moles. Okay. Then we divide it by kilograms of water. Okay. We know that there's 200 grams of water. How do we convert from grams to kilograms? Okay, you can divide by 1,000, or how many places do you move that decimal point? Okay, 3. Either way, we should be dividing it by 0.2000. Okay, so go ahead and divide. Okay, what are we getting when we divide 0.139 by 0.2000? 0.695. Do you agree with that? Okay, your unit for molality is a mole per kilogram. Okay, so for every 1 kilogram of water, there's 0.695 moles of glucose in it. Okay, this time we're going to figure out what mass of sodium chloride must be dissolved in 500 grams of water to create a 0.75 mol-al solution. Okay, so mol-al, do you see how that has like molality? Okay, so this time you're given the molality, so it's 0.75. And molality equals moles per kilogram. So we're going to solve for moles. And 500 grams of water is equal to how many kilograms? Okay. Move that decimal. 3 to the left, so 0.5000. Okay, how do we solve for x? What do you do with those two numbers? Okay, multiply these. So what's 0.75 times 0.5? Okay, so the unit of this is moles. So in order to make this 0.75 mol-al solution, you need 0.375 moles of sodium chloride. However, what's this problem actually asking for? What's the second word? Mass. What unit is mass? Grams. Okay, so we have to take this one step further. Do we know how to convert from moles to grams? Okay, we have to find the molar mass. So sodium plus 1 chlorine, 22.99 plus 35.45. What do we get? $58.44. Okay, then we just multiply. So what's 0.375 times 58.44? $21.9. Okay. That's okay. Okay, so that means you need 21.9 grams of sodium chloride to make this solution. Okay, so now we're going to figure out, well, how do we actually calculate like how much the boiling point of a substance can change? You do need this top equation. Write down this top equation. So this is how we calculate that boiling point elevation. I have a typo. Okay, so let's look at this equation. You don't necessarily have to write everything below. You just need to make sure you know what these symbols stand for. When you look at an equation, what does this triangle symbol usually mean? Change. Okay, so it's a change. The T is temperature and the B is boiling point. Okay, so it's how much does that boiling point change? Another way we can word it is it's that boiling point elevation. KB is this mol-al boiling point constant. Okay. This number will be given to you, and it's a constant. However, it changes depending on what your solvent is. Okay. So whatever the solvent is, I'll give you that KB value. Okay. And then finally, lowercase m is molality. Okay. So I'd make sure you know that lowercase m is molality. But besides that, you probably don't need to write all of this down below. All right, so this equation just tells you how much the boiling point changes. Sometimes you're asked to calculate like the overall boiling point. To find the overall boiling point, you just find the boiling point of the pure solvent and then add whatever you calculated for the boiling point elevation. Most of the time, our pure solvent is going to be water. What's the boiling point of water in degrees Celsius? Okay. So most of the time it's water. Water boils at 100. So you just take 100 plus whatever that boiling point elevation is, and that'll give you the new boiling point. Okay, we're going to do one practice problem where we calculate the boiling point. Okay. So we're going to find the boiling point of a solution of 1.5 moles of glucose in 500 grams of water. The Kb value for water is 0.512 degrees Celsius. All right, so we're going to use this change in temperature equation. So delta TB is just equal to Kb times M. All right, Kb is given to you, so we just have to find M. So M is molality. So it's just our moles of solute, which is 1.5, divided by our kilograms of solution. Okay. This problem gives you 500 grams of water, so what's that in kilograms? Okay, so remember, just move that decimal 3 places. So what's 1.5 divided by 0.5? Okay, so molality is 3. So now we can just plug it in the equation. Okay, so Kb is 0.512. And then we times it by molality, which is 3. Okay. So just 0.512 times 3.
1.5.
Will you say that one more time?
1.5.
Thank you. Okay, so this number right here, it's just the change in boiling point. Because Kb is in degrees Celsius, this will be in degrees Celsius. So boiling point goes up by 1.536 degrees. Okay. But that's just the change. We want the total boiling point. Okay. Your solvent is water. So what's the normal boiling point of water? Okay, so we're just going to take 100 plus this 1.536. Okay, so the new boiling point of this solution is 101.536 degrees Celsius. And pause for a second and ask yourself, like, does that make sense? So, like, when you add salt to your water that you're trying to boil, does it change the temperature of your water drastically or just a little bit? Just a little bit, right? Like, you're not going from 100 degrees Celsius to 200, right? Like, you're not melting things. So keep that in mind. Most of the time when we do these, you'll have small answers, right? You're just changing that boiling point or freezing point a little bit. It's nothing huge. We're just going to look at freezing point. Freezing point is pretty much the same thing with just some letters that change. Okay. So our equation we use for freezing point is just the change in temperature for freezing, okay, or freezing point depression, is equal to Kf times M. Okay. So Kf, again, is just this molal freezing point constant, and little m is still molality. So if you already wrote down like these symbols on the previous one, do you really need to rewrite the meanings of them? Okay, so for this slide, you probably just need this formula. Okay, and then if we want to calculate the freezing point of the solution, we just take the freezing point of the pure solvent, and this time, since it goes down, you subtract the change in that freezing point. Once again, usually our solvent's water. What's the freezing point of water in Celsius?
0.
Okay. So usually you're taking 0 degrees Celsius minus whatever you got for that freezing point depression. Okay, we're going to do one practice problem. We're going to calculate the freezing point of a solution of 2 moles of sucrose in 500 grams of water. The KF value for water is 1.86. All right, so this time it's the delta TF because we're looking at freezing. And it just equals KF times M. What does the lowercase m stand for? Okay, that lowercase m is this molality, so it's moles of solute over to kilograms of solvent. So how many moles of solute is in this solution? 2, right? 2 moles of sucrose. And it's dissolved in water. I give you 500 grams of water. How many kilograms is that? So we're 0.5. So what's 2 divided by 0.5? 4. 4? Okay. So now we can just plug it in the equation. Okay, KF is always given to you. So 1.86 times 4. Okay, what are we getting? 7.44. Okay, because KF is in degrees Celsius, this will be in degrees Celsius. Okay, and it's freezing point depression, so what does that mean? It's going to go down. So then the way we calculate freezing point is you take the freezing point of water, which is 0, and because it's a depression, you're going to subtract 7.44. Okay, so that means this new solution, instead of freezing at 0 degrees Celsius like pure water would, this one freezes at minus 7.44 degrees Celsius.